Hi, my name is Mihai Dragan. I work for Imagination Technologies, and I would like to show you some of our exhibits, our demos here at the Embedded World 2025 in Nuremberg.
So what's the latest? Are you talking about language models, AI?
Sure, since you mentioned language models, we have a demo here showing a large language model implemented by one of our partners on one of the PCI Express cards.
Is on this one?
No, the PCI Express card that we're talking about is not featured here. This is just a demonstration of input and the...
So it's like an AI accelerator for a computer or something like that?
It is a GPGPU, so it's a typical GPU that also has a compute pipeline, which our customer used here to implement a large language model. So it's Perf XLab, and the GPU in question, it is an XDX PCI Express card.
How does it compare with having a big NVIDIA GPU in your server rack or PC?
They're aiming for a similar market. They are, the GPUs themselves, they are smaller in size. However, more affordable. They're free to integrate in any designs our customers might choose. So unlike other silicon vendors, we are not silicon vendors at all. We only sell IP that can be freely integrated and customized into various SoC designs, so they can serve more flexible functions.
Is this a very advanced, is it from something from Meta, or what is a language model right now? Are you running DeepSeek 671 billion?
No, this is something that Perf XLM implemented. We don't have any, I couldn't tell you more details, but if you went to their webpage, you will find out more
about this. So what else here are you showing at the booth?
Oh, one project that we're really proud of is the first iteration of our open source driver stack. So this is a board.
It's 100% open source?
Yes.
Everybody can take it, improve on it, or use it completely.
Correct.
To the last, what do you call it, transistor, like full performance?
Well, the driver stack itself is open source. What we see here is the BeaglePlay board from the Beagle Foundation. It's a low-cost, low-power, small form factor, single-board computer. The SoC itself on the back is
TI?
Yes, a Texas Instruments Sitara AM62.
Which has Imagination GPU?
Yes, with features, one of the smallest GPUs we've probably released in the last 10 years. This is the AXE 116 GPU.
And it's smooth. And it's an AM625 SoC.
An AXE, AM625 SoC with an AXE 116 GPU. Right. Let me tell you a few words about the driver stack itself. So we have native Vulkan support, and on top of having the low-level Vulkan support available, you can then, with translation layers, get support for OpenGL ES, for example, through Zink and other high-level APIs.
Is this an ARM SoC?
The CPU itself, yes, is ARM. I think this particular SoC features 4 Cortex A53s.
All right. And so you've been doing GPUs and ARM SoCs for 2 decades, long time.
That's correct, yes. But more recently, we've had really great success in the RISC-V market.
So there are some chips with the RISC-V right now that's using your GPU?
We don't have any on display today. However, we are the preferred choice for RISC-V SoCs.
All right, what do we see around here?
So this is a demo showing a driver monitoring system. So video processing, trying to determine whether a driver is safely focusing on the road.
And multi-core where is doing AI software development system, or?
So the AI software is implemented on top of the OpenGL compute libraries in this case, and it's running on the typical GPU using the compute pipeline.
And what do we see here?
So this is a comparison of different workloads of different backends and basically technical data for them.
All right. all the cool things at the booth you want to show?
Sure. The one that I personally worked on, I'm going to save this for last. So this is a Texas Instruments AM69 SoC and their starter kit. And it features a mid-size GPU, the BXS 464. The SoC itself is quite beefy, featuring 8 large CPUs. And this makes it a great platform for showcasing our hardware GPU virtualization capabilities. And what we see right here are 2 applications running on separate hardware interfaces of the GPU. So all of our GPU models have hardware support for virtualization. Essentially, they offer what we call hyperlanes, which are dedicated hardware interfaces that we expose to the upper layers, like the operating systems. They can be passed through to virtual machines, and this is what we've done here.
Virtualization is directly on the SoC, and there's a reason to do that because you want to connect different. Is it different OS? Oh no, what does it do?
Yes, we have a different. We prefer Linux for ease of use. So we have a Linux host system and a Linux running inside a virtual machine with KVM acceleration.
And what's the performance decrease when you do the virtualization?
Well, because we do, this is one of our key points of our technology. Because we do pass-through rather than software virtualization, the performance is near native. I was talking about the hyperlanes. So these are real hardware interfaces that they're given over directly to the drivers running inside the virtual machines. So there is no need during runtime for power virtualized communication. The driver doesn't need to extend over through the hypervisor to a host driver. Everything goes directly between the GPU and the virtual machine.
So are we looking at some good performance right here?
Yes, this is a small to medium GPU destined for...
Is it Doom?
It is a WebGL application from WebGL samples, and I think they make more interesting demos than the typical HMIs you see in.
That looks cool.
In industrial
and what
scenarios.
Is happening here? Is it both running on the same or is it different?
They're running on the same GPU, but different hyperlanes. And what we're seeing here is a cube mapping example.
All right. So latest in graphics and AI, that's what you're showing here, the embedded world?
Correct, yes, this is our focus for this year.